The A320 is equipped with dual-wheel main gear, which retract inboard, and a dual-wheel nose gear, which retracts forward. The wheels of the main landing gear are equipped with carbon brakes for efficient braking even at high temperature, an anti-skid system, an automatic braking system. The nose gear is equipped with nose wheel steering. The ECAM wheel page displays indications for the main landing gear, nose landing gear, landing gear doors, and brake temperature. In the center of the ECAM wheel page, green and amber messages can be displayed to provide normal and abnormal indications. Since the wheel page is displayed during landing, spoiler position is also displayed at the bottom of the page for quick reference. Let's go to the cockpit to locate the controls and indicators for the landing gear, brakes, and steering. The landing gear selector lever is located on the center instrument panel. Just above the landing gear lever is located a panel which contains switches and indicators for the landing gear, the auto brake, and the anti-skid and nose wheel steering. Up, down, and unlock indications on the gear panel are associated with position indicators on the wheel page. When auto brakes are used, selection of low, medium, or max is made using these push-button switches. This switch controls both the anti-skid and the nose wheel steering through the brake steering control unit, the BSCU. Left in the on position for all normal operations, it is switched off only in case of specific malfunctions. The landing gear gravity extension handle is located on the center pedestal. The steering hand wheels are located on each side of the cockpit, so either pilot can taxi the aircraft. The rudder pedals can also be used to steer the aircraft. Note, United Airlines policy states that only the captain may taxi the aircraft using the hand wheel. During taxi, either steering hand wheel can be used to control the direction of the aircraft. The steering hand wheel provides 75 degrees of nose wheel deflection, left or right. Signals from each hand wheel are summed up. If two hand wheels are moved in the same direction, the nose wheel deflection will be equivalent to the sum of the hand wheel commands. During taxi, the flight controls must be checked. To check the rudder pedal disconnect switch must be held down. This button disconnects the nose wheel steering from the rudder so that full deflection of the rudder pedals can be checked against the indications on the ECAM flight controls page. During takeoff, the aircraft direction is controlled exclusively using the rudder pedals. The rudder pedals provide up to 6 degrees of right and left deflection at low speed. As the speed increases, this deflection angle decreases progressively until 130 knots, when directional control is 0% nose wheel and 100% rudder. The rudder pedals are located on each side of the center pedestal. Manual braking is provided using the top of the rudder pedals. The parking brake handle is located on the center pedestal. The A320 provides two braking modes: normal braking, brake by wire; alternate braking, conventional low-pressure hydraulic signal. Normal braking, which is powered by the green hydraulic system, utilizes electrical signals which are sent to the BSCU, Brake Steering Control Unit. The normal braking provides auto brakes, manual brakes, and anti-skid. Alternate braking is powered by the yellow hydraulic system. The alternate system is backed up by a hydraulic accumulator. The alternate braking provides anti-skid, depending on failure, parking brakes, and manual brakes. This is a schematic of the green normal brake system. Electrical signals from the brake pedals activate the BSCU, which sends a signal to open the normal selector valve. Hydraulic pressure then opens the automatic selector valve. Pressure is modulated by the anti-skid system to the normal servo valve. Note, in the green system, there is no pressure indication shown on the triple pressure indicator. When auto brakes are used, electrical signals are sent directly to the BSCU from the auto brake system. The normal selector valve is opened, allowing pressure to open the automatic selector valve. The normal servo valve is modulated by the anti-skid. The ABS uses signals from wheel tacks and the ADIRs to compare the actual deceleration rate to the selected rate. When 80% of the selected rate is achieved, spoilers, reversers, drag, a green deceleration light illuminates. Once again, there is no pressure indication shown on the triple pressure indicator. If green brakes fail, or if the anti-skid and nose wheel steering switch is turned off, the yellow system takes over automatically. The normal selector valve closes. Yellow pressure pushes the automatic selector valve open, allowing hydraulic pressure into the alternate brake system. The brake pedals send a low-pressure hydraulic signal to the dual valve. If anti-skid is available, the alternate servo valve modulates the pressure. When using alternate brakes, there is pressure indication on the triple gauge. If the failure has also caused the loss of anti-skid, the alternate servo valve will open fully. The pilots must monitor the hydraulic pressure on the gauges. Brake pressure must not exceed 1,000 psi. The parking brake handle is located on the center pedestal. When activated, the control valve opens, allowing yellow hydraulic pressure from the pump or the accumulator to lock the brakes. All other braking systems are deactivated. This gauge, which is located on the main instrument panel, measures yellow system pressure only. The AccuPress, or accumulator pressure, will always register accumulator pressure as long as the aircraft is powered. The brakes gauges measure yellow pressure to the left and right wheels. When normal or green pressure is active, these gauges read 0.